In this video, we'll be looking at organic chemistry and a bit of the alkanes as well. And I'll show you the specification and we'll just tick through all the points of the spec as we go through. So this is the spec. You can pause and read some of the terms. This is what we'll be looking through. And the same with alkanes. After the introduction, we'll look at this. Both of the alkanes is linked with the introduction, so I thought I'd do that both at the same time. What is organic chemistry? I think it's a very important question, and it helps you to understand why we study it and why it's so important in life. So it's a study of carbon compounds. Carbon is in group 4, so it's 4 outer electrons. It's neither easier to lose or gain 4 electrons to get a full outer shell. Therefore, it prefers to share the electrons. And carbon can form 4 bonds because of this 4 covalent bonds, and it can form these long chains, and they can be infinitely long. Here's an example, but they can be infinitely long, and that gives us so many possibilities of potential compounds. So here are some examples of organic compounds, and you can see here that the study of organic compounds can help us understand life. All organisms are made from these hydrocarbon chains. So the study of organic compounds can help us understand life, help us sustain life. These are all foods are made up from hydrocarbons. It can help us advance life. Many of the energy we use are hydrocarbons. And it can help us extend life. All drugs and medicines we use are organic compounds, and it can help us enrich life with our plastics, fabrics, and perfumes. So organic chemistry is one of the most complex but most important topics you'll probably ever come across. So organic compounds are so varied, we can group them into families depending on their functional group. Now the functional group is just the part of the molecule that reacts, or the reactive part of the molecule. In IGCSE single chemistry, you learn about 6 of these families. You learn about the alkanes, the alkenes, the alcohols, the halogenoalkanes, carboxylic acids, and esters. Whilst in IGCSE double award, you learn about 3 families, and that's the alkanes, the alkenes, and the halogenoalkanes. You may touch on some of the other ones like alcohols and carboxylic acids, but it's only those 3 are the main ones. So please do check your updated spec as to what exactly you need to know, and indeed in this video we'll only be looking at exactly what you need to know in the spec. Okay, so I thought I'd start with looking at the different types of formula for your alkanes, your family of organic compounds called the alkanes, which are hydrocarbons and the simplest form of hydrocarbons. You don't need to know about alkenes, so we won't be doing that. Please do give yourself some time to answer the table and to answer some of these questions here. If not, just go on to the next slide for the answers. So these are your answers for the table and for the questions underneath. For empirical formula, for the first thing, I just want to write down the definition of that, just as a recap. So it's the simplest ratio simplest whole number ratio. Simplest whole number ratio of atoms. That's your empirical formula. It might ask for a definition there. Your general formula is given here, and that formula is the same for all. Same formula for the whole of the homologous series, and then your displayed formula. That's another definition that the exam could ask, and that just shows all bonds and all atoms. Okay. So going now to number 4, it also asks you to draw a displayed formula. So your displayed formula for number 4 will be like this. Your carbon has 4 bonds because it's in group 4, bonds to hydrogen 4 times, 4 hydrogens. You have your bromine atom. Now this is a substitution reaction, so your hydrogen a hydrogen atom on the methane on your organic molecule swaps places with the halogen atom in the halogen molecule, and they react to form. So we get a substitution and mono-substitution reaction, and your bromine atom now becomes part of the organic compound, and that becomes this is now part of a different family. This is called a halogenoalkane. And you also get a gas, and that's hydrogen bromide. That is a gas because it's not dissolved in water. You can dissolve this gas in water to get an acid like hydrobromic acid or hydrochloric acid if you had HCl, but if they're not in aqueous or gas, they are just hydrochloric acid. There are two types of reactions that you need to know, both double and triple, that alkanes undergo, and that is complete combustion and substitution. But first we'll look at complete combustion. You might need to write balanced chemical equations for these combustion reactions. So methane, you should know, CH4. Anytime we combust something, it is always in oxygen, and this is complete combustion. You will need to know in complete combustion, but we'll look at that in a different video. So we have complete combustion. There's more than enough oxygen. So we have CH4 plus O2 reacts to form, and anytime in combustion, you always have the same products. That's carbon dioxide and water. Now your carbon is fully oxidized to carbon dioxide, and your hydrogen is fully oxidized to water. So now we just need to balance it. So once we write out these equations, let's do butane as well, which is C4, and then we're going to have twice as many carbons plus 2 because it's an alkane, so we're going to have 10 hydrogens plus our O2 reacts to form again CO2 plus water. That is the same with all complete combustion reactions. Okay, your carbon is fully oxidized to carbon dioxide. Now we need to balance them. When you balance them, always balance them in this order: the carbons first, then the hydrogens, then the oxygens. And that's just because the carbons are the easiest to balance, then the hydrogens, and then the oxygens, and that's because the oxygens are found in the most places, and then hydrogens, you have multiples of them, so they are a bit harder than carbon. So the first one, our carbons are balanced on both sides. There's one on both sides. You've got 4 on one side and 2 on the other side, so I need to put 2 in front of here for the hydrogens. Now the hydrogens are balanced, and then the oxygens, I've got 2 oxygens on the left, and then I have 4 on the right, so I need to put a 2 in front of here. Now our oxygens are balanced. First equation, balanced. With our butane now, we have 4 carbons on the left hand side, 4 on the right if I add a carbon there, so our carbons are balanced. Sometimes we do need to go back, but if we balance them CHO, normally our oxygens just balance, sometimes can balance themselves out, but let's see. We have carbon, let's go into hydrogens. So we have 10 hydrogens on the left hand side, and we have 2 on the right hand side, so we need to put 5 in front of here. Now our oxygens, we have 8. We have 2 on the left hand side, then on the right hand side, a bit more complicated, we have 8 here, and then we have 5 here. So in total we have 12. We have 13. So 13 divided by 2 is going to be 6.5. Now with our oxygen molecule, we can have halves, and that's because if it splits in half, it's going to split into the same thing. Okay, it's a symmetrical molecule. If it was an unsymmetrical molecule like carbon dioxide, it can't be split in half. Okay, so that equation is now balanced. So we balance our hydrogens, balance our oxygens. That's balanced. Okay, let's look at our substitution now. We have ethane. That's C2, and it's H6. And now we're going to substitute that with, let's say, chlorine. Let's do chlorine and propane. We've got CH3, H8. Okay, that follows a pattern. It's just the next one down from ethane, and next row down. And then let's do bromine here. No, let's do iodine. We haven't done iodine yet in this video. So we have chlorine and iodine. So when these react in substitution reactions, as you know, we have a mono substitution reaction. We have our chlorine swapping for one hydrogen. Okay, so it is mono substitution here, and that happens in both of these. Now we get here C2H5Cl plus our HCl. Okay, then here we have this is 3. C3H7, so we lose a hydrogen, and we replace that with our iodine atom, and that's plus HI. Okay. Now we might need to name these. We've got ethene plus chlorine. We know that. Let's name just our organic molecule here. Let's all just do our products actually. So we have ethane. This is going to be chloroethane, and this one's going to be iodo. Apologies for my handwriting. Iodopropane. Your gases are going to be hydrogen chloride, and then hydrogen iodide. Okay. Okay, here's some practice now. You may want to pause the video and complete these equations on a rough sheet. And with your substitution reaction, let's have a substitution reaction with fluorine because we haven't done that one before. Okay, so you may pause now. Okay, so pentane is because of the prefix here, we know that we've got 5 carbons. So let's do that. 5 carbons plus, pentane, 5 carbons. Therefore, we're going to have 12 hydrogens plus our oxygen, because that's what happens in combustion. You always react with oxygen, and that's going to form our carbon dioxide plus water, as we already know. Now to balance them, let's balance our carbons first, okay, and then our hydrogens. We've got 12 on this side, we've got 2 on this side, so let's put 6 here. Then our oxygens, we've got 2 on the left hand side, we have 10 here plus 6, we've got 16, so it's just 8 there. Great. And then substitution reaction, let's do butane, so we have C4H10, and then plus our fluorine. We're also going to name our products as well, so if you haven't named your products, just pause the video now and name them, or think about them in your head. We have C4H, so we lose a hydrogen, so we're going to have 9 plus our fluorine atom plus hydrogen fluoride. Okay, so our name here is fluorobutane, and then we've got hydrogen fluoride. Sorry, it's a U. Hydrogen fluoride. Okay. Okay, so the rest of this video is dedicated to PowerPoint past paper questions, and this is the intro to the past paper questions, so please do read it if you want to go forward with the past paper questions, and the answers will be on the slide as well to the questions, so it will be very useful. I'll quickly go through them. Okay, so I'll give you give yourself 2 minutes to answer these questions, and then press pause, and then play after for the answer. Okay, so the general formula for the alkanes is, you should know this, is 2n plus 2. And then the general formula for cycloalkanes, you won't know this. It's not something you're required to know, but you should be able to work it out using the table. And if you use the table on the previous slide, then you'll find out that it is CnH2n. Now you want to count the carbons and the hydrogens and find out what the ratio is there. Next one, I'll give you 2 minutes as well to answer this. Bear in mind, this is triple only. This is only triple. So if you're double, you can skip this question. Okay, the answers are any of these properties you can have. Same chemical properties or similar. Graded physical properties or trending physical properties. You can't have same physical properties because they don't have the same physical properties in the same group. If you have methane, as opposed to another member of the hydrocarbons, C50, let's say C50H102, and they're going to have different physical properties. They're going to have different colors, totally different colors. There can be different states at room temperature, different flammability, and all of that stuff. So it's graded physical properties. Okay, same functional group or CH2 group. Okay, again, give yourself 2 minutes for this one. You may want to scribble some stuff down. Okay, the answer for this. So heptane is saturated because it contains single bonds only, and M2 heptene is unsaturated because it's got a double bond. Now here, some students say it's got instead of saying a double bond, they say because it contains 2 bonds. Now 2 bonds could be 2 single bonds. You have to say a double bond. Again, this is 2 minutes. You won't have learned the cycloalkanes, but you should be able to apply your knowledge to cycloalkanes here. So your answer for ethane is this, and your displayed formula for cyclobutane is this. And you can see that that should follow the general formula that you wrote earlier, which is CnH2n. Again, 2 minutes for this. Okay, ultraviolet light substitution. Ultraviolet light is the substitution reaction, and this is what you should have got. You replace 1 hydrogen with a bromine atom, and again, this is applying your knowledge to a different scenario. Okay, so we've gone through all of these points now. Just please do pause and just check to see you're comfortable with all the points that are highlighted. Again here, check to see if you are comfortable with all the points highlighted as well here.